Wang to present his paper on sports narrative enhancement with natural language generation. Henry, please.
Hello, hello. Okay, cool. Nice. Everyone's got to get my attention right now. We have a much smaller audience now. Yes. Awesome. Thanks, everyone, for staying and till this moment. You made it so far. And I want to especially thank Connor, actually, for setting up the stage, talking about a lot of things I'm going to be covering right now. So I'm going to stay mostly at the high level. But I think this application of using natural language processing or generation in sports, we find this to be an interesting application in sports. And my colleague, Samang, and I, we actually worked together with Abi, who's from Fox Sports, on this particular use case. So really glad we can be here today, and I'll speak on behalf of the team to share some of the learnings and findings we got on this one. So for the agenda today, we're gonna introduce the problem, do a quick summary of the action and results, give an overview of the methods. Then we're gonna take a little bit of a deeper dive into the methods, specifically talking about how do we fine-tune large language models such as T5, and how do we pick the metric for our evaluations, and how do we use some of the natural language processing techniques such as back translation and paraphrasing generation for this particular task, and how do we put them all together to build an end-to-end pipeline that could be used for the production system. Yeah, so for the problem introduction, in a nutshell, what we want to achieve with this project is that we want to generate a human-readable narrative from tabular data for broadcasters to convey these messages to the audience. So when certain events happen during the game and when these milestone events happened, like the broadcasters definitely want to capture those and be able to tell them to the audience in a very short amount of time. What's happening right now is because there's so much amount of data outside that it's very hard for human brains to grasp like really how to make sense of all the stats available. So a rule-based template is usually applied to stitch all these tabular data together. So the broadcasters have to maintain a large amount of templates as well, because there are different conditions, different situations, different stats, and different players all together. And they need to put all these tabular information together to form an output of a sentence. And these are usually a fixed structure sentence because it's rule-based, right? So certain times when a lot of information needs to be packed in there, such as you could have a rigid and awkward phrases. So one example is you look at the input here, Bobcats, which is a team that maybe Amazon will introduce in 20 years. But they have a 10-1 game, and the time is on September the 1st. There's 32 other teams out of the league. So what you could see from the template is Bobcats' 10-1 game in September is the first most out of 32 in the NFL, for example. And there's really not an easy way for them to fix it except for manual interventions, right? And this problem gets especially challenging if you don't have the ground truth about what a good narrative is. So it's very up to the broadcaster to say whether they want to talk about this message or not. And if this sentence is too long, sometimes they can just skip this message because it's even hard for them to understand what's really going on in this narrative. So what our team did is that we treat this problem as a natural language generation task. We're thinking about whether we can introduce a machine learning solution to replace existing template solutions and make it easier to maintain and also more scalable for future sports and other use cases. So we built the solution on top of this pre-trained language models, and we break the problem into two stages. The first one is to replicate a template with machine learning models, and the second stage is to enhance the readability of it. Our results, we actually got above 99% blue score for the first stage of trying to mimic the behavior of the templates. And then for the second stage, we got an average of 13% improvements in readability compared to the original narratives coming out of the template solutions. So here's a method overview of what we did. You will see in the input, you have different stats in tabular form. Some of them could be acronyms related to certain stats used by the broadcasters. So what we did is we fine-tuned T5 model, which is a large language model. I'll talk briefly in the next couple slides. And then fine-tune this model with just a couple hundred narratives so that the machine learning model will understand the positional meaning of different inputs and then try to put them together that will generate an output similar to what the template solution will generate. And then for stage 2, we apply the back translation and paraphrasing. Both of those are commonly used natural language processing techniques among various NLP tasks, but we find a way to combine them together so that you can actually use this sort of unsupervised way to improve the readability of the final output of the narrative. So you see how this stage 1 output looks quite different from the stage 2 output. So let's talk about template to ML first. And let's talk about T5, text to text transfer transformer. So this is actually a very large language model that was released in late 2019 or early 2020. And what this model does and what it was trained on is actually it looks at 750 gigabytes of clean text that was crawled from online. And it trains the model on various downstream tasks. So what this model can do is actually amazing and very powerful. You can give it a text sequence, and it will give you a sequence output. For example, you can say, translate English to German, this is good, and then you will have the German output. You can ask it to say whether you can calculate the number, like what is 1 plus 2 equal to, and it will give you a string output of 3. You can also say, summarize this text and what's the key information I want to get out of this. And you get this one at the end. So this model and the language models, in our experience, we find it's really powerful that you actually leverage a lot of the information from the pre-trained text and that it can be used and fine-tuned for a lot of downstream tasks. So for our particular case, we could actually easily pass in the tabular inputs and then ask the model to say, okay, generate a narrative for me based on out of these inputs. And then the model is able to look at a couple examples. You could almost call it a few shots, and then it will output these narratives for you. So the second stage, which in our opinion is a little bit more challenging, is how do we improve our readability without a label, without access to ground truths about what comprises of good narratives. And the unsolved problem is also what's readability anyway, right? This is a very subjective term. Like everybody could have a different opinion about whether they like a more structured sentence or do they like the sentence to be broken down into different pieces to be easier to be consumed. So what we did is actually we looked at around all the different metrics and we find this concept called perplexity to be a nice proxy that can allow us to do an evaluation of the quality of the sentence. So here are two examples. Can you do it? It's a real sentence. So what those large language models, when they see this common sentence, will actually assign a low perplexity score to it. However, if you give it a fake sentence, can you does it? The language model will get confused because they have never seen such sentences before from the online text or the cleaned up crawled text. So they will be like, okay, what's going on? And then that perplexity score basically measures like how confused they are when looking at the sentence. So an example here is you have the 10-1 game and then the first most out of the 32 in the NFL this season. So the perplexity score for a GPT-2 model, which is another large language model, will have a score of 70, where if you change those words to be more natural like 10 games won, and then the highest out of 32, then the model actually assigns it with a lower Perplexity score. So what we're going to be using for our model evaluation is we're going to use this as a proxy to how well our sentence read. So next, we have this specific technique called back translation. So what this technique is commonly used is actually for a translation task, say translate from English to Spanish or Chinese or German. And you translate this original sentence into an intermediate language, and then try to translate this language back to the original sentence. And what this step does for you is actually, the large language model, they have seen all the correct translations from the past. And then when they see this back translation part, they will actually replace the awkward phrases with the more commonly seen phrases during the training part. So this is a very neat application of back translation in trying to replace some of the phrases in the original template solutions to a more natural machine learning output. And then for paraphrasing, that's another commonly used NLP technique. What paraphrasing or paraphraser does is that it generates these semantically similar but syntactically different sentences. So for example, you have this original sentence as an input. Now you're asking the language model, okay, give me some variations of how you would try to talk about this differently, but maintain the original meaning of the sentences. So there's actually some online data set that we can train this paraphraser model on. So there are data sets which tells you whether two sentences are paraphrases with each other or not. So you can pre-train the model on those labeled like classification tasks, and then change the last layer of your neural network model to let it generate those texts without any supervision on it. So in this right side of the slide, you can actually see a couple candidate sentences as an output from this paraphraser. And this is the, exactly the data set we're talking about. So you have the sentence 1, sentence 2. If they are not paraphrases, you get a label of 0. If they are paraphrases, you got a label of 1. And you fine-tune T5 models using the paraphraser pairs. So finally, how do we tie everything together? Because broadcasting is a serious business, and we want to make sure that no information got left out, or you don't introduce errors, actually, during all these transformations using machine learning. Because one of the cons of using language model is that their behaviors are really hard to control as they are probabilistic-based models. So how can we make sure that the output we get out of this pipeline is the desired one we want? So we designed this template, and we designed this pipeline, actually, to tie everything together. So for the first part, you'll see we take the tabular inputs together. We got, using machine learning, we got this either a template or a machine learning output solution that's similar to the template model output. Then we go through this enhance back translation step. So the reason we went with back translation first is we also take into consideration of the inference time and the latency. Because back translation, by nature, it's just doing 2 steps. You translate to a different language and translate it back. So it takes less computational times. Whereas for paraphrasers, it's actually generating a lot of different candidates, and you try to choose among those candidates. So we do the back translation first, and we look for whether the features that was present in the original tabular inputs were presented in this output. If it does, great. We output the back translation result directly. If it doesn't, then we go back, or we go to this next phase, which is enhancement using a paraphraser. And similarly, we check whether the keywords are present or not. And if by the end, the keywords we find somewhere that's not output, we will actually just from the pipeline directly generate this original ML output or the output that's similar to template to make sure we capture all the key information. However, if during this process that we find there are better alternatives that still maintain the key information, we will output those. And here's just quick slides about the results we have seen. So actually, you can see what's the distribution from the pie chart, like the final output from this pipeline. We do see actually about a little bit less than half of the output are coming from the original or the ML output from the step 1. And when we take a deeper dive into it, we actually find the keywords mapping we're trying to look for them, it's very rigid. And one of the enhancement or improvement we can do in the future is actually find the similar meaning words to include them in the mapping. And then if you generate some words that share similar meanings, we can also make them pass those criteria. So this is a potential output of what the model give us to. And think about the applications. We can actually use this, for example, during the live broadcasting, but we can also use this to send out like a Twitter feeds, for example, right? Summarize what's happening during the game and send it to, say, the fans who are particularly interested in this particular player or the team, so that we make sure they always get this most updated stats, like about what's happening in the game. So some of the learnings we take from this project, we find that large language models can be generalized to unseen cases fairly well. And one of the reasons we're proposing this pipeline also is that if you have new players introduced into the leagues, or you want to introduce new stats into the game, as we see ever increasing, this is happening right now, we can easily do that. And you actually don't have to have a lot of manual interventions or creating more templates in order to adjust to these change. And the second thing is that natural language processing and NLG are really, we are at the front of these technologies, right? And in order for us to explore like the production use cases, we do find having some post-processing steps or pipelines can be helpful to make sure our results are desirable. And for the future extensions, one thing you may be wondering, like, why do we go through these multiple stages, right? Like, so one extension of this work could be you have this final output from the machine generative model pipeline, and then you use that model to train a classification or supervised task that you just take the inputs from the game and then outputs those results. And the other generation is that you can actually think about different vocabularies to include for your models and to make sure, okay, which ones do you want to make sure to include in this final output? And then you can have more varieties out of that. So with that, I think that's the end of the presentation, and we will have Q&As. Thank you.
Thank you. I really enjoyed your paper. I work for ESPN. My colleagues asked me to make sure you don't win the competition, so you're going to put a lot of people out of work. Okay, so one technical question, then a couple of kind of general questions. The T5 model, in the earliest stage, you said you fine-tuned it, I guess with transfer learning. How did you supervise that? What were the examples or tags or supervised information that was able to fine-tune that?
Yeah, absolutely, absolutely. And so for this particular fine-tuning task, we actually worked with Fox Sports on seeing like, okay, can you permutate the data for us? And then let's see what are the template-generated results look like. And let's just use a couple hundred of those to fine-tune the T5 model for the first stage. So with that, you could actually, not to replace existing templates, but actually to enhance and to allow you to actually see, okay, this is a template-generated results, this is ML-generated results. And until you gain enough confidence on the ML results, then you can say, okay, let's go with that route. Yeah.
Okay, more general question. I know this is outside of the scope of what you did here, but the immediate thought to me was using actual closed caption transcript of events or descriptions or recaps and things like that, or even like summary articles of games to train the model. What do you think about that?
That's a fantastic proposal, I think. This is one thing we were also considering, the closed captions. So one challenge with using a closed caption is that, do we have a method to ping those closed captions narrative back to what actually happened during the game? Like if we do have a really good mapping from that, then definitely we can look at like what our human language narrative looks like, right, out of those events. And can we use those as sort of like a golden standards to train the model or teacher enforcing the model to say, okay, generate narratives that seems just as natural as the ones you get from those closed captions models. But for our particular cases, we actually don't have access to that. But I think that's definitely an interesting extension for future work.
Yeah, I think it would work better for like a play-by-play description than the analysis component, or the narrative component.
Right.
Okay, last question from me is, as cool as this is, I think the real challenge is the stage that comes right before this, which would be some sort of filter that estimates how relevant or interesting the nugget is, and that would be a wonderful thing. So one of the big things we do at ESPN is kind of pre-event research. Like what are the interesting things going into a game that you want to know about going into a game? And so if we could automate that task, so we have oceans of tabular data, if we could just crawl through that and produce that automatically, that would be good. So what do you think about that challenge? Have you thought about that?
Are we talking about replacing other broadcasters' job right now? No. I think, joke aside, I think that is absolutely something we want to use technology to empower. And especially like when you have an ocean amount of data, right? It's really hard to know, okay, whether this event is of particular interest to the audience, right? Or whether it's worth talking about or highlighting when the game happened. So I think there are different efforts going on, like sometimes they are using statistical method to say, okay, you have the distribution from, say, all the yardage of the passes historically, right? Now, if you get a Hail Mary pass, that's like 50 yards out, then that's a very significant event. So we look at like the distributions of those events happening and compare them to the common distributions you see historically, and maybe that's just one naive solution of using a rule-based solution, right? But other than that, like I think there could be also integration of saying, okay, can you use natural language searching to actually search for like relevant information or similar stats from the past, right? For this particular player or this particular team, and then you can make interesting comparisons during live broadcasting. I think that's another functionality we're looking to.
Yeah, I think it was very cool. Obviously, I'm not an NLP expert, and the application in sports media is pretty obvious, right? Instantaneous highlights, like we talked about, push notifications, if done well. What are some other non-obvious applications that are exciting in sports from this?
Yeah.
Beyond what we talked about the searching, for sports media.
Definitely. I think what Connor presented earlier, right, using the BERT model and just carve out a couple of these sequence of the plays is a very interesting application. And if you apply that over and you say, okay, trying to predict the trajectories, right, like what he's doing right now, I think that could be an interesting thing. First of all, to see, okay, whether you can do those what-if analysis. Like, if you have the trajectory predicted, how does this tie into this final outcome of the game, of that put? Right? Or you look at the sequence of a player, then you can say, okay, whether they are, like their form is good, for example, or whether there's anything that's statistically significant that's different from the ones you commonly see from others. So I think applying these sequence modelings do have a lot of interesting applications. And it's really everyone's job at this forum here to find those and work towards them. Yeah.
So one quick thing just in terms of the analysis. I liked the way you looked at the perturbing the paraphrases and sort of, essentially extracting the common component that seems to keep coming out of those things. But you could also do this across similar situations, right? So you could, I think, not just look at, perturbing the paraphrase for the statistic you're looking at, but look for, let's say, other statistics about QBs and other things, and extracting that from other games to get more, just more information from that. That's just one minor thing. And then I was thinking in terms of other applications, it seems like this would be great for narrative for, as we know, betting on players, right? FanDuel is really big. Applying this to give narratives to people that want to bet on individual players and do that seems like that would be a huge business. And I'd also suggest, why not use this for some of the, sports broadcasting is one thing, but financial news broadcasting is even more dire need
Absolutely.
of this kind of thing. And that's 24/7, by the way. So, but very
much larger market for sure.
Yes,
Yeah.
it is a lot more dollars too.
Yeah.
No, this is really interesting, and I think there's a bunch of interesting things you could do here.
Thank you.
So,
Thank you.
Cool.
Appreciate
Thanks.
it. Yeah, actually, just one last comment to your comment. We actually are looking into different applications of these. Like, can you summarize the game, for example, taking all the contextual information from the game, right? But also, like, can you write news together by saying, okay, this game happened, like, say a derby, like a racing game happened, right? Like, can you describe, like, what really happened in the game? And can you describe, like, the profile of the horses, for example? And also in, say, the medical field, right? Can you describe the characteristics of the medicines or the new product that different pharma companies are producing, right? Obviously, there's a much higher stake for those medicine world, but I think the application of this and extension of this is really huge.
Well, actually, if you're interested in doing that on the finance side, Brian Kelly at Yale has done all this stuff with a century worth of New York Times and Wall Street Journal articles, which is essentially creating narratives for the economy. But anyway,
that would be of vast interest to our team. So we will
you guys
definitely
should
connect.
talk.
Thank you very much. Thanks everybody. Yeah.